In this video, we will learn how to find whether the two goods are complementary or competitive. The question is, consider the demand function of two goods x1 and x2 respectively. Demand for good x1 is equal to p1 raised power minus zero point 0.7 times p2 raised power 0.2, and demand function of good x2 is equal to p1 raised power 0.6 times p2 raised power minus 0.4. Where p1 and p2 are the prices of good x1 and x2, we have to determine whether the goods are complementary or competitive. Okay, so to see whether the goods are complementary or competitive, we need to find out the sign of the cross elasticity. Okay, if cross, let's denote it by, if you know if cross elasticity comes out to be negative, we have a condition of complementary goods. Okay, if cross elasticity comes out to be positive, the goods are said to be competitive. Okay, all right, let's calculate the cross elasticity. We are being given demand function. Let us find out the cross elasticity of good x. So let's denote it by E. Okay, EC. So cross elasticity of good x1 is simply the change in the quantity of good x1 due to the change in the price of good x2 times P2 price of good 2 times quantity of good x1. Okay, this is the formula, simple thing. Cross elasticity simply tells us the rate of change of, rather we can say, how quantity demanded of good x1 changes due to the change in the price of good x2. Okay, so let's calculate this derivative, that's del x1 upon del p2. Okay, so let's first write what we have been given here. We have this kind of x1 is equal to p1 raised power minus 0.7 times p2 raised power 0.2. Let's calculate the cross here. Okay, that is del x1 upon del p2 here. That means differentiating this function with respect to p2. So derivative of p2 0.2 will become coefficient. So we have 0.2 p1 raised power minus 0.7 times p2, though, so the exponent of p2 will get subtracted by 1, that is 0.2 minus 1 is minus 0.8. Okay, now then what will be the cross elasticity? So let us see. So cross elasticity will be equal to dx1 upon dp2. We calculated it as 0.2 p1 raised power minus 0.7 p2 raised power minus 0.8 times p2. So let's write p2 divided by x1. X1 is this p1 raised power minus 0.7 p2 raised power 0.2. So let us see what happens here. So we have 0.2 p1, so this gets cancelled here, p1 and p1 gets cancelled. Then we have p2 raised power minus 0.8. Then we have p2. If I transpose this denominator to numerator, exponent sign will get changed and it will get multiplied also with this p2. So we have p2 raised power minus 0.2. So we get here 0.2 p2 raised power minus 0.8. So here bases are same, or let's write it here. Here bases are same, we can add up the exponent. So we have, let me write 0.2 p2, we have minus 0.8 plus 1 minus 0.2. So this comes out to be 1 minus 0.8 comes out to be, so this all will get, or let me write it here, it will become 0.2 p2 raised power minus 0.8 plus 0.8. Okay, so it becomes 0.2 p2 raised power 0, which is equal to 0.2, which is a positive thing here. So we got cross elasticity of demand. So we got elasticity of demand, cross elasticity of demand equal to 0.2, which is positive. So we can say that two goods are competitive. Okay, if the sign of this cross elasticity of demand between good x1 and the price of good x2 came out to be negative, we would have said that the goods are complementary. Similarly, you can check for cross price elasticity of demand for good x2. Okay, so if I have time, let me calculate that also here. Okay, let's first rub this to make sure we are doing this. Let's calculate it for good x2 also. Okay, so cross price elasticity of demand for good x2 will be equal to change in the price of good x2 with respect to, change in the quantity demanded of good x2 due to the change in the price of good x1 times price of good x1 quantity demanded of good x2. Okay, so since x2 is equal to quantity demanded of good x2 is p1 raised power 0.6 p2 raised power minus 0.4, we need to first calculate del x2 del p1, differentiating with respect to p1 partially. So we have 0.6 p1, 0.6 minus 1 is by power function rule, it becomes minus 0.4. Then we have p2 raised power minus 0.4. So cross elasticity comes out to be del x1 del x2 divided by del p1, which is this 0.6 p1 raised power minus 0.4 p2 raised power minus 0.4 into p1 divided by px2. X2 is p1 raised power minus 0.7 p2 raised power p2 raised power 0.6. We have p1 raised power 0.6 and p2 raised power minus 0.4. Okay, so here you can see this p2 and this p2 gets cancelled. We are left with 0.6 p1 raised power minus 0.4. Then we have p1 and then this p1. If I transpose, exponent sign will get changed, so we have p1 raised power minus 0.6. Okay, so this comes out to be 0.6. Bases are same, we can add up the exponents. We have here the exponent is 1, we have minus, let me write it here, 0.6 p1 raised power minus 0.4 plus 1 minus 0.6, so we get 0.6 again. Okay, so again the cross price elasticity comes out to be positive. We say the two goods are competitive. Okay, I hope I make myself clear in this video. Thank you.